Morning, guys. So today we're going to be working with quadratic functions, which I'm sure you are a little bit familiar with from Algebra 2. We're going to be converting them from standard form to vertex form by something called completing the square. I know you have learned this before, but I'm sure you've probably forgot some things, so let's get started. Let's first go over what we know about parabolas, right? Parabolas are this shape, right? Quadratic functions are in the shape of a parabola, okay? We have our axis of symmetry, right? Which cuts the parabola right in half symmetrically, okay, vertically. We know that the vertex is either the lowest point or the highest point, right at the little tip there, okay? If your A is positive, right? Remember, it's like a happy face, so you have a minimum point down here at the bottom, okay? If this A is negative, then it's down like a sad face, and you have a maximum point at the top of the vertex right there, okay? So that we've already learned about parabolas, okay? This is standard form. Remember the ax squared plus bx plus c, okay? This is vertex form. Okay, and it's called vertex form because when you look at it here, you can easily identify my vertex, which is HK. So once I find my vertex, I know exactly where my parabola is going to fall, and I know that my axis of symmetry is going to go right there through the vertex. So whatever H is, it's going to be the line x equals H, right? So if this is a 2, it's going to be x equals 2. This line is the axis of symmetry. Okay, so you'll notice that there's a nice perfect square right in the middle of vertex form. So what we're going to be doing today is we're going to be turning this form into that form by completing the square. Here's an example of vertex form. Identify the axis of symmetry. If it were in standard form, you'd have to do a little bit more work to find the axis of symmetry. But in this case, I know that my vertex here is going to be positive 3, 1, right? My H and my K. So right over here, positive 3, 1. This is going to be where my vertex is. I know that A is positive, so I know it's going to be up like this, and I know my axis of symmetry is going to go right through this line, x equals 3. So my axis of symmetry, all I have to do is look right here at what my H is going to be x equals 3. All right, so example here, my axis of symmetry is x equals 2. Here, it's x equals negative 5. Okay, remember it's opposite H, so if it's a plus 5 in here, it's negative. And this is going to be x equals negative 4. So it's very easy in vertex form to identify your axis of symmetry. All right, so, okay, let's get started. Here is an equation in standard form. Here is an equation in vertex form. These are the exact same function, okay? If I put them both in my graphing calculator, it is the same exact graph. Okay, so what I'm going to do is I'm going to turn this into this, all right? So we're going to do something called completing the square. I know in math I can do whatever I want to an equation as long as I follow some rules, right? I can't change anything in the equation because then it's not really, you know, I'm messing around with it. I can manipulate it, but I can't change the value of anything, right? So if I add 5, I have to subtract 5, right? You have to undo whatever you did, if that makes sense. So let me show you what I mean. So the first thing we're going to do, okay, again, I want to make this look like this. So f of x equals, all right, I want to have x squared, right, minus 6x, okay? I'm going to just take my x's and I'm going to add a little space because I'm going to add something, all right? And then I have plus 5. And now, because I don't want to change the value of anything, whatever I add, I'm going to subtract, right? If I add 5 and then subtract 5, I didn't really do anything, right? I didn't really change much. So how do I know what I'm going to add? I am going to make this into a perfect square, because this is a perfect square, right? X minus 3 times x minus 3. So I'm going to you take half of whatever b is, right? This would be your a, this would be your b, and that would be your c, if you're talking standard. So you take half of b, and then you square it. I seem to think it's easier to kind of just do it mentally, but if you like to do it on the side, that's fine. So half of negative 6 is negative 3, negative 3 squared is 9. Now, it's always going to be positive, right? Because it doesn't matter if it's a negative times a negative, right? It's going to be positive. So you don't even have to worry much about the sign. It's always going to be positive here. I'll say it again. Half of negative 6 is negative 3, and negative 3 squared is positive 9. All right, so I'm adding 9, and then I'm going to subtract 9. Okay? Now, I'm going to erase this so it's not in my way. Okay, so now I have this little piece here. I just made this into a perfect factorable square, right? So if I factored this, factors of 9 that give me negative 6, this is going to be x minus 3 squared, isn't it? Right? If I factored this, wouldn't you go like this, and then you go factors of 9, that give you 6, so you get x minus 3, x minus 3. That's what you're looking for. Okay, so instead of writing it all out, I'm just going to write it as x minus 3 squared. Isn't that the same thing? Here's a little hint. Whatever half of b is, that's what you're going to have in here. So if you start working with fractions, that's an easy way to see what's going to be in there. All right? If this is negative 3, half of this is negative 3, this is going to be negative 3. All right? And then I have 5 minus 9, which is negative 4, right? And now I'm done. Do you see how I just manipulated this equation to make it look like vertex form? And I can easily identify my vertex here is positive 3, negative 4.